I'm back at the definition page, and my next definition is the complement of an event. It is denoted by E bar. The bar is that little line that's on top of the E. Is a set of outcomes in the sample space that are not included in an event E. So if my event is having a boy, the opposite would be having a girl. So E is a boy, E complement would be a girl. So a theoretical or classical probability, this is the probability based on the outcomes in the sample space. The formula is given right here, but the idea is that you need to count how many things are in your event and divide it by how many things are in your sample space. So a good example was the last example, where we were trying to find the probability of having 2 boys and a girl in 3 children, in a birth of 3 children, and we found that it was 3 out of 8. Now the difference between the theoretical or classical probability is and the empirical probability is the empirical probability depends on the actual events happening. So the flipping of a coin has 2 outcomes. It's either heads or tails. Now, if you flip a coin 10 times, are you guaranteed that 5 will be heads and 5 will be tails? Well, the answer is no. So the theoretical probability is the probability of getting heads is 1/2, but the empirical probability, you will then go ahead and flip a coin 10 times and count how many heads you got this time. And I bet each time you're going to do this experiment, the empirical probability will change just a little bit, because it is not possible to get exactly 5 heads, 5 tails each time. Now, the law of large numbers states that as the number of trials approaches infinity, the empirical probability will approach the theoretical probability, meaning if you flip a coin infinitely many times, you will actually get half of them to be heads and the other half to be tails. There were experiments done, mostly in prison, but there were experiments done with flipping a coin many, many times, and the more times you flip a coin, the closer that number gets to a half.